sentence transformers to the rescue, and those are going to be the stars in the show today. All right, sentence transformers, Nils Reimert and Irina Kurevich, 2019. What's going on here? I will start with the training data. So the way that you used to train a sentence transformers is you have one sentence, how to learn C, how to learn C++, a second sentence, and you have a gold label of cosine similarity that some expert came up with. So you need two sentences and an expert that gives you a cosine similarity. Rather involved, but that's the way it worked before. And you have two birds sharing weights. You get embeddings out of the birds. You get pooling. You get cosine similarity that spits out a result. You compare it with the gold label, and the backpropagation works its magic to hopefully improve the embeddings so that they match with the gold label. And you get great embeddings. So that's the magic. It was state of the art. Nowadays, it's more or less the same, but with different structure of the training data. I left the slide here just in case of reference, in case somebody wants to train their own. But the cool thing is that you do not actually need the cosine similarity gold label. You have losses that work well just with sentences. And I will show you what I mean. So this one is one of the many, many losses in the ways that you can possibly structure your training data. But this one is called triplet loss. You have a query, also called an anchor. What can I do to get better grades? You have one positive example. How do I improve my grades, which is supposed to be very close to the anchor? And you get a bunch of negative examples. Like, how do I get better grades even though I study a lot? How can I get better grades in maths, which is very close to the query, but not quite. And the task is pull the positive examples closer to the anchor, push the negative examples further away from the anchor. And it's super important to have great negative examples, because if they're very easy, not a lot of learning is going on. So when I first saw this loss, I said, cool, very easily we can train our own. But that's not really the case, because you need great negative examples, otherwise the trick doesn't quite work. So, but I hope that gives an intuition into how folks train sentence transformers nowadays. So you need losses kind of like that. And folks did train sentence transformers. We had a million options to choose from. Good thing is that they have introduced these lovely tables giving us performance comparison on a lot of data sets, and also speed, which is important when you deploy anything, and also model size, which is equally important. So we took a look at that, read the documentation, chose 3 of those, and started evaluating. All right, so what's going on here, just so that we can keep the setup going. They seemed like an amazing contender, more or less. Also, 9,000 stars on GitHub. People are using them actively, building issues, commenting, people responding. So people are using that. It's not something rather new that you would fear being in production. All right, I will show some code, no slides for some time. To start coding, we needed to set our project